Okay, I've generated or saved CMOS EDU13 library, and I added some net lists that we can simulate. And I want to simulate these using HSPICE. So I'm going to go over to my Preferences, Tools, Spice, set it HSPICE 3 Standard Output, Run Report Output. I'm going to change that back to Run Ignore Output, Run Probe. This is exactly what is seen on the web page. Let's see, right here. Okay, so if you're confused, you can copy what this shows. Now, note in CMOS, the 0th lecture, when I was talking about setting up HSPICE, I copied this here. Well, I forgot to copy the location of the executable. So that's copied and pasted right into here into Run Program. So this bin hspice.exe is nothing more than what was copied right here. Okay, and again, I'm on a low resolution display. So let's go do some sims. Okay, so we're set up HSPICE, SPICE level 3, standard output, use node names, run ignore output. Hit OK. I've got my bind keys set up so I can write a SPICE deck by pressing S, and I can plot SPICE for this cell by pressing P, and I'm going to use those in the following discussions. So let's simulate this, a circuit which is ID versus VBS for a PMOS device of 40 by 2. And let's press S. Now go to File, Simulate. Now HSPICE will generate wants to see SP files, so let's hit SPI, which is what electric generates, and there's our net list. Notice I have it as SPI files associated with LTspice. I wouldn't be surprised if in future generations of electric you can select on the setups that it generate an SP file so you can bypass this step. Okay, so we open it. Now it's open the file. Now it's going to say, what do you want to output the file? We need to keep the base name here so when we go to plot, it knows what file we need to plot. So save, and then it runs. And now we can press P for plot, or let's show one more time here, SPICE. Plot SPICE for this cell. Now, there's several things we can do. Let's look at the DC signals, or the sweeps, because I did 5 or 6 sweeps. I'm going to plot I of the voltage source here. I'm going to come over and increase the size of that panel. I can go and hit Tile or Window, Waveform Window. We can do this several ways. Adjust position, tile horizontally, tile vertical. This is vertically, this is horizontal. I'm going to press T and tile vertically. Go over here, fill the window. Go over here, reduce the size, or hit fill. So fill the window. I can turn the grid on. Shows the grid. I can right click on the trace, select the trace, right click on it and change the color. I can change the lines versus points. Let's deselect this. There's points and lines. It's hard to see on this resolution, low resolution, and then there's both. I can zoom in using the zoom feature. I can hit fit and show it. I can expand. Notice even though I did a DC sweep and this is volts, it shows seconds. There's probably a way to change that. Let's see what else. I can drag other signals over. I can either right click and add to current or add in a new, or I can just drag it over into here. And of course there's no current flowing in the bulk ideally, and I can delete that trace. Whoops, I deleted all of them, so let's go ahead and replot, add to current panel. Whoops, I gotta add a new panel. Hit fit, expand the size or shrink the size. Grid's on, reread the simulation data file, update waveforms. So I could go in here and I could change the size of the transistor and resimulate, etc. Okay, so that's one example. Let's close this window, and let's also hit Tile, Fit. Let's do another one. Let's do a transient simulation where this is just an NMOS device with a output or capacitor initially charged to 5 volts, and we're pulsing the transistor, and we're going to look at the output. Before I do that, let's go look at the directory. Note how I have my simulation netlist, got my HSPICE output HSPICE output files, I guess. I could go back in my setups and pick a different directory to store the netlist and the output, so I can make this C:spice if I didn't want my simulation data to clutter up my basic directory that I'm using for my library files. So anyway, let's go back and simulate this. Press S. Then we'll have to go to File, Simulate, and again, HSPICE wants to see SP files, so it looks for those, and so we have to change this to SPI. Then we go over here, and it says Output File Save. Okay, now I'm going to hit Plot, and then let's go ahead and show this. Not sure why that's still there, but let's plot V out, V in, tile the waveforms, reduce the size here. We can expand by pressing zoom out, expand, or fit, or zoom in. If I want to zoom in, I press Z. We can zoom in here. We can put the cursors back on, hit fit. We can go do measurements if we want. Pull things down and zoom in. What else can we do here? We can, again, zoom out. We can go change the colors. It's, again, hard to see on this low resolution screen all the things that we can do. You can look at the, there's only one simulation here, so there's only transient signals. Let's see what else. Oh, when I select this waveform over here, I can see the cross probe feature. I can select this waveform here. It shows what the waveform is. Hit fit. Oops, select the window, hit fit, etc. Let's go ahead now and close this. Or actually, why don't we change this capacitive load? Control I. Oops, cancel. Select the value rather. Press Control. Control I. And then change the value to 500 femto. We should see a ×10 increase in this delay. Resimulate, File, Simulate.spi, NMOS. Save. Yes, I want to replace it. Okay, now if I want to reread the simulation data, I can click on that. You see the delay went out. Alright, so let's go modify our setups. Fit. Go to Project Settings. Oops, I'm sorry, Preferences. Go to Spice here. Let's run Report Output and run Probe. Say OK. Press S. File, Simulate.spi. Open. There's the file we'll simulate. And then output file, save. You want to replace it? Yes. Again, if we were able to output SPI files directly, or SP files directly, we could bypass all this, I believe. So hopefully, this is an external process. Then let's hit Tile. And there's our reporting directly. And our signals, we can look at the current. There's no current flowing through there. We could delete this trace. Whoops. Hit the delete button. Hit the delete button. There's our current. You can right click here, set the axis to logarithmic, linear, etc. Let's go ahead and right click on this one. Delete. Let's add this to current panel. Add this current panel, etc. Again, right-clicking, change the colors and highlight, zoom in. Let's see what else. Rewind to start, stop moving axis for scrolling. Not sure why these are sitting up there. I'll report those and see what happens. Let's go back now and set it up so that it runs, instead of using these, it runs LTspice externally, which is the way I use it most of the time because you need to have a license to run HSPICE, and LTspice is free. Project setting, oops, I did the same error. Project preferences, Spice. Let's go to Spice 3. Don't run. And we're good to go with that. So say OK. Close this, tile, fit. Press S. Let's call this _SCH. And of course I could call the outputs different names as well. I can go back to my Explorer. There's my file NMOS CL transistor. And let's plot V in and V out. And there's my simulation using LTspice. Alright, lots of stuff you can do here with integrating the simulations, etc. We'll post these waveforms. Let's quit CMOS ED or the electric and then stop.